Well, hello everyone. It's so lovely to see so many of you joining us this afternoon. So just a quick welcome. My name's Fiona Goddard. I'm one of the educationalists at Whizz Education, and I've also got a colleague with me.
Oh, right, I'll introduce myself. My name's Andy Clay. I just recognise some of the names on there. I do work with some of you, and I work with schools, actually, in schools alongside Fiona, with schools across the UK.
Great. So we've got a packed session this afternoon. It's going to last about 40 minutes, maybe 45 minutes, depends how chatty you are with us in the chat. And talking about the chat, you can only see what you put in, because we've decided if you try and see all the other people as well, it becomes overwhelming. So we can see everyone's chat, but you can only see the chat that you put in there. But please use the chat, because we really want you to engage with us this afternoon with the different activities that we're going to do. Now, also, the activities, they're great fun, but we're going to go at quite a pace because we want to keep you interested and just to show you a whole host of different things. But that means that you might struggle to keep up with us. So maybe it's best to sit back, watch, engage in the chat, and then there's a handout that comes out after this session today, and it has all of the activities, so you can then do the activities another time at your own pace and maybe explore it even further, which would be absolutely great. So, how many have you been looking at the screen whilst you've been waiting for us to start? We've got 7 different pictures up there, and we're asking you to estimate how many you think. For example, how many polar bears do you think are left in the world? How many leaves are there on a tree? So, what do you think? Start putting all your responses in the chat for us. And we'll start to have a go. So Andy, whilst you've been waiting, have you been having a go at this?
I was thinking about the tree one. I guess it depends on the sort of tree, doesn't it? So I'm going to hazard a guess that's possibly an oak tree there. So I don't know, about 100,000 leaves, I would guess, because they're pretty big.
It's quite a few.
It's a very dense tree, isn't it, that one?
It is. Right, so what's coming through on the chat?
We've got something for the number of times a bee flaps its wings per second. We've got 5 for that one.
5, right.
Yeah, that seems like quite a sensible estimate. I don't know if that's quite right or not.
Well, a second goes so quickly, doesn't it? You think just start to move your hand. How many times can you wave your hand? It's not that many, is it? So I wonder how many times a bee can flap their wings per second. This is my favourite one, actually, because this one astounded me.
Yeah, I'm guessing because the buzzing noise of a bee is the wings moving, isn't it?
Exactly that, it is.
So I'm guessing maybe it is a few more than that then.
Yeah, well, do you know what? 200 times per second. I mean, I don't know who managed to count that. I guess they did slow the coverage down so they could actually see and count, but roughly 200 times per second a bee flaps their wings. I love that fact because it just astounds me, as I said. What about stripes on a tiger? Have you had a go at that one, Andy?
I think the way I did this one last time, I think, was I counted the stripes on sort of one side, and then I added the 4 legs on as well. So I think if I'm counting up the black stripes in there, it's going to be a bit of an estimate, I guess. Yeah, so 20 on the body. There's 2 sides of that, isn't there? So 40, maybe looking down the back legs at any rate, another, say, 10 per leg, so another 40, so 80. Tail, 100, and the face, I would say 110.
110, okay. What do you think? Let's see. Anyone else put anything in the chat? Just having a quick look to see. Oh, some are saying way more than 100 in the hundreds. Others are saying less. So it looks like, you know what, you're right. It's around, because obviously every tiger is going to be different, but around 100 stripes.
Oh, right.
Over it, yeah. So
that's good. Maybe I remembered that from last time then.
maybe. What about the female turtle now? This always fascinates me because I've watched on TV when the female turtle comes out of the sea and they go up the beach and they obviously make their nest on the ground and on the dry ground, and obviously lay their eggs. And then what I've seen is the footage where all these tiny turtles are then racing to get back to the sea before the big predators that are around come and actually grab them. And it's quite a rush back to the sea. So I'm guessing the number might be quite a few, just because I've seen so many little baby turtles rushing back. Oh, so we've got some guesses coming through.
Yeah. I've just noticed as well, we've got some answers going in the question and answer part, so I'll keep that open as well.
Ah, okay, brilliant.
We stick with your turtle eggs for the moment.
So some are saying between maybe 10 eggs, some are going into the hundreds. What do we think? And, you know, the person that put, or the schools that have put the hundreds are actually right. Obviously, it's hard to say, and the female turtles can do this between 2 and 10 times a year because they lay eggs quite regularly, but it's about 110 roughly eggs they lay each time. That's a lot of babies to look after, isn't it? So yeah, so that's the eggs. Oh, any others? What about polar bears? This is a sad one, isn't it? Because
it is. We've got a suggestion on here of a fairly exact number, actually, 102 polar bears, which is a depressingly small number, isn't it?
I really do hope there's a few more than 102 polar bears.
Yeah, we've got somebody else saying between 500 and 1,000 though as well.
Right. Okay. So
quite a small amount.
The scientists say, obviously, this is around the whole world. They reckon that they say fewer. That I don't know when at the height of when we had loads of polar bears what the number was, but they reckon there's roughly about 26,000 left in the world, which does sound a big number, but it's not really. I know they're concerned for the polar bears. And also concerned because a lot of their habitat is disappearing with the ice going. So yeah, right. I think rather than, I'm just looking at the time, this is on the handout, so you can have a go at this. So we're not going to do them all. So maybe you can have a go at the icebergs and the African parrots, and maybe try and find some facts yourself, and get some of your mates in the class to have a guessing game as well of how many. But there's a reason why we've chosen these particular things today. They're all to do with our natural world, either within the environment or the actual creatures or insects, because as we've lived on this earth, as we all know, and we've heard it in the news, just the behaviors of us with our litter, with all of our fossil fuels and things like that, we've been actually causing damage to our environment. And obviously we know that climate change, where the earth is starting to heat up by certain degrees, and that is obviously having a devastating effect on things, but also with our big Amazon, our forests and things like that, with trees being cut down. So much is happening that actually is causing a lot of damage. Now I'm going to share with you quite a frightening fact. So let's go to the next slide, because we've just jumped to, because they reckon, so we're year 2022, so they reckon by the year 2100, so that's only how many years? Let's do the maths. That's not many years. I don't think I'll be around then, but I know a lot of you will be. They reckon by then, so it's in our lifetimes, an estimated 50% of all the world's species could go extinct because of climate change. And climate change is all down to us and our behaviours. So we had a big think at Whizz, and we thought, do you know what? We just need to make sure that everyone's really aware of their environment, of what's around them, and the impact sometimes of things that we do, the impact that can have on our environment. So we've got just a plug here. We've got a summer challenge, and I don't know if any of you have been having a go at some of these projects, but the challenge is for you to have a go at our projects. We've got 8 mini projects, all to do with sustainability, looking after our environment, and we've called it Building for a Greener Future. Now, we call them STEM activities. There's all sorts of science, technology, there's maths, there's even art in there, just so it's crosses lots of different areas of the curriculum, and they're just good fun, but they also just make us think about where we live and how we're looking after that. So I really hope you can download those activities. You can do them in school, or you can even do them at home. You know, you can just do one activity, or you could do all 8 projects. It's totally up to you. So, but it's really versatile. It's really good fun. And certainly schools that we've been talking to have been having a go and really enjoying the activities. So that's our theme for today. So I'm going to go to the next slide, and Andy's going to take you through some more fascinating things about nature.
Yes, so just picking up on what Fiona said, we thought we'd start off carrying on with that nature theme, but obviously, we're Maths-Whizz and Whizz Education. We're going to bring some maths into the nature as well. So I just wonder if you've ever looked around the natural world and noticed any shapes and patterns, because maths forms the basis for a lot of these building blocks of the natural world, and you can see some really quite stunning pictures if you look carefully. So we've got a few of our favorite examples on the screen. So in order that you can interact with us and give us some answers as well, we put a number against each of these pictures. So what I'd like is for 2 things, if you could, if you just say number 1, for example, what shape can you see, first of all? And then the second part of it would be, what do you think that shape is in that particular case? So same thing, if we could put some answers into the chat. You don't need to do them in order. We can do them in any order you like. And then we'll see how close we get and how many we can get through. So it sort of goes down vertically, 1, 2, 3 in the first column, and then 4, 5, 6, and so on. Some of them might be fairly obvious, I'm hoping, in terms of what they are at any rate. So somebody's straight in there with number 1. So exactly like that. So number 1, a honeycomb. Perfectly correct. Honeycomb, you can see the shapes of that honeycomb. What sort of shape is that? We look at the number of sides. So straight away again, number 1, a different school this time. Number 1 is a hexagon. It's a hexagon from a beehive. So perfect answer for number 1. So I'm hoping probably that most people would get that one. That's probably one of the more regular shapes that we can see on there, isn't it?
Yeah, and the most challenging one, actually, when we've been doing these extravaganzas, the most challenging one has been number 8, but we have had some schools that have got that one. So you're up for a challenge now. See if you can find out what you think it is. So that's quite a difficult one.
So we've got somebody getting I was going to say object, the creature correct for number 2. So number 2 is a giraffe. So that's sort of fairly close up of a giraffe's skin. What sort of shape would we say those are? They're not necessarily regular shapes, are they?
No.
So I just need to count the sides. Or please, jump in with something else as well.
I would say someone's just popped in number 11. They've put is a spider's web, and they said that they can see some quadrilaterals, but also some circles. So that's a good one.
So we've got 2 votes just come in for snakeskin for number 3. So I'd say that's correct. And we've got 1 suggestion on there of hexagons. I'm always confused on this one. I think hexagons is a good answer for that, because there are 2 sides, aren't there? 2 quite small sides.
Yeah.
Going vertically on each of those.
Yeah, I have had people before say it's a rhombus. So it's a really difficult one, that one.
But yeah, I will take that one as hexagons for the snakeskin. So number 10 as a sunflower. Again, we're really good at guessing the objects on this one. What about the shapes for the sunflower? What sort of patterns can you see? I guess might be an easier one.
Yeah.
It's a very pretty pattern, isn't it, going around? Also got somebody saying number 4 as a tortoise shell. No shape though for the tortoise shell as yet. And impressed that somebody's got red cabbage for number 7. So circles and spirals. Yeah, I
Yeah.
guess, yeah, if those are joined together, I think that's pretty good. That is quite an amazing looking shape, actually. If you look at it from a way back, it's almost, it's like sort of star shapes, isn't it?
It is.
Each
Yes,
concentric inside each other.
it is. It is. Yeah.
Was it, which one was number 8, wasn't it? That you sent
Number
me
8's the
the
challenge.
hardest one. Yeah,
Really tough
so
one.
number 9, we've got pineapple and semicircles. Certainly the green bits on there above the yellow bits on the pineapple there are semicircles, aren't there? There's a few other shapes in there that are a bit more tricky to name, I guess. But yeah, certainly green semicircles on the pineapple.
Yeah, I can see they've said 6 is a tree trunk with some circles. So
Yeah,
yeah,
got a
I'd
few other
agree with
people
that.
saying yeah, exactly agreeing with that in the chat as well.
Yeah.
Got
Oh,
spirals for the sunflower, somebody's come back with as well.
right. And number 5. Now this is a really interesting one because it looks like stones or paving slabs, doesn't it? But it's actually natural. It's been formed naturally. It's in Ireland. I wonder if anyone's put anything coming through. Oh, it says yes. I see some people saying yes, stones and things. But it's actually the giant causeway in Ireland. And yeah, those actual slabs that you can see have actually been formed like that. I just think it's incredible that nature seems to be doing quite a lot of hexagons. Have you noticed that, Andy? Yeah.
Is that because it's a particularly strong shape, do you think?
Well, I think a triangle is the strongest shape.
Mm.
But, yeah, I don't know. Maybe it's just, don't know. That might be a good thing
Yeah,
to challenge people to see if they can find out.
I
Yeah.
could do a degree in biology. I should know the answer to that. I don't, unfortunately. We've got a couple of suggestions for number 12 while you've been saying about I think it's basalt, isn't it, on number 5 for the Giant's Causeway?
Yes.
I'd not noticed this before because I'd obviously not been looking closely enough. Number 12, we got a leaf. Somebody suggested little squares, and I was sort of looking at the bigger veins on that. But
Yeah.
if we look inside those, there are definitely, or maybe need stronger glasses, there's definitely quadrilaterals in there, and I think they are squares as well if we look at certain of them.
Yeah, I just find it fascinating that there are so many shapes in nature that are just formed naturally. It is.
We've got somebody going for your number 8 as well.
Ah, okay.
So we've got leaves and spirals. I think spirals is absolutely the sort of pattern we can see, isn't it there? Is it, again, I can't remember this one, so is it a leaf?
Well, it's aloe vera.
So
it's a plant that I've seen it when I visited Cuba, actually, growing there. And I think it's it's something you can put on your skin that helps your skin if you've got some sores, or and do know it's a drink now that you can buy from a supermarket as well, aloe vera. So, and once again, I think it's got some good health benefits. But certainly number 8 and number 10. We're not going to go into this today, maybe another time, is also to do with Fibonacci as well, and the numbers in nature linked with Fibonacci. But I've told you the name if you want to have a little Google of that and see if you can find out more. But yeah, very, very interesting. So talking of shapes, should we move on to the next activity, Andy?
Yes, absolutely. It sort of leads on quite nicely, doesn't it, from what you were saying about hexagons. Oh, about some of the shapes you were mentioning just then. So what we've got on this one is 4 shapes, one of which I didn't just give away by accident, but 4 shapes on there. So again, we're after things from the chat here. I mean, it's going to be obvious, isn't it, Rich? Which is one of them anyway, from what you were saying just now. But what we want you to do is to, first of all, name the shape. So the easiest way to do that would be, so yellow is whatever shape and so on. So can you name the shapes? And then which one of those shapes is the odd one out? And why do you think it's the odd one out? And there's more than one correct answer to this question. So, why do you think a particular shape might be the odd one out? And it could be any of the shapes in actual fact. So first of all, we need to know what the shapes are called. So would anybody like to give us a colour and give us a shape name for that one?
Well, hexagon's coming through because I think you gave that one away.
I sort of rather did give that one away. So hexagon we've got to begin with.
Yeah.
I think there's one more probably fairly easy one on there, and then maybe the other 2 are not quite so obvious. So what have we got there? Yellow hexagon, we've got blue as a parallelogram.
Oh, now I give you a clue
Hmm.
because this might help, because I don't know what your screen's like that you're watching this on, but with the blue shape, all of the sides are the same length. So that might help you, because a parallelogram obviously has two sides, the opposite sides, don't they? The same length. So this is different. They're all the same length.
So if we stretch that blue one to make it longer horizontally to be a parallelogram.
Yeah. So we've got red trapezium. Let's have a look. Yeah, well done.
They're coming in thick and fast now. People are going for the harder ones first, actually.
Yeah. Oh, I'm really pleased that a lot of you are actually not just saying triangle, but actually giving the name of the triangle.
That's brilliant. That's better answers than I've had before.
Which I haven't written, but it is an equilateral triangle. You are absolutely right. So what about the blue one? Coming through. Yeah, it's a rhombus. Well done.
So we've named all four of those. We got those in pretty fast order, in actual fact. So we've got the first odd one out here. So the triangle, because it's got an odd number of sides rather than an even number of sides. Perfectly correct, but not necessarily only one correct answer.
Yeah.
Very good answer, but what other answers might be, and what other shapes might be the odd one out? Because it could be that one, it could be any of the others as well.
Yeah. I'm going to have a go. I'm going to say the trapezium is the odd one out because it's the only shape that has one set of parallel sides.
We've got something similar coming almost to
right.
run alongside that one. So the blue one is the odd one out. So the rhombus is the odd one out because it's the only one with an even number of parallel sides.
That's great. Minds think alike. Well
done. It is, isn't it? So again, yeah, both correct. Let's see. Well, I was going to say the hexagon then, because it's the only one where all the internal angles are the same, but that would apply to the triangle, equilateral triangle.
Yeah.
Well, different angles, obviously.
You could say all the interior angles are obtuse. That would be a good one. Any others coming through? Well, I'm just wondering, whilst some more come through, I'm just going to take you somewhere else to show you the shapes that we've just been looking at. Just to have a look at the interior angles, because there is something quite special going on with these four shapes. And you can maybe start to think about that. So I think we'll take the equilateral triangle first, because I think hopefully you'll know the size of the angle in an equilateral triangle. Has anyone started to put that in the chat? What's the size of the angle? I've got my angle measurer. So we know it's acute, it's less than 90 degrees. And if I move it round, I can see people starting to put it in the chat now. You're absolutely right. Oh, no, it's not 58, is it? I need to be a bit more precise with my measuring. There we go. So it is, the internal angle for the equilateral triangle is 60 degrees. And each one of those, if I spin it round, each one of those will be exactly the same. So
we've had somebody go even one further than that one and saying, a total of 180 degrees in there.
Wow.
So they were obviously following along very well with you there.
Yeah, good. So, and let's go to the hexagon. And here we can see, because if I move my angle measurer back to, oops, I'm being a bit there. Oh, it's really hard to be exact with the mouse. Right. So that's 90 degrees. So as I said, it's an obtuse angle. So it's larger than 90 degrees. Anyone like to have a guess? I'll keep going, keep going, keep going. It's 120. Well done. It's all spinning through now. Well done. 100.
So we are getting these coming through. They're almost coming through almost exactly as you're saying them.
Yes.
Well,
so
I don't think it's people copying you. I think it's just the people are seeing it as it's happening and typing as quickly as they possibly can.
Absolutely.
So very well done to those 1, 2, 3 people who put that in.
So we've got the triangle with interior angles of 60. We've got the hexagon with interior angles of 120. So what do we think? Now we've got a quadrilateral. So what do we think these interior angles are going to be? Now, if we look carefully, we can see that these angles are the same, but these aren't the same. So these are different. So, but these two are the same. So remember I said there's something special about all these shapes that we've chosen. What do we, brilliant, I love it. People are now guessing my question. Oh, so sorry, right, sorry. But guessing my question. So you're absolutely right. It is, oh, let me just try and do it exact. Oh dear. 60. You're absolutely right. And that was spinning through. And I got so excited when I saw the chat, I clicked the wrong button then. You're absolutely right. So that's 60 degrees here. This will be 60. But if I turn our trapezium round so we can see the other angle that I was
we have got somebody who's ahead of you here as well, but I'll not read it out just to give it away to everybody else. See if we get anybody else
right.
back with a similar answer.
Yeah, thinking about the numbers that we've been working with. So once again,
somebody else as well has already worked this one out, so all good.
So here we go. It is, you're absolutely right, 120. So within the trapezium, we've got 60 and 120. And if we add all those up, anyone know what they total when we have a quadrilateral? And look, my rhombus, you can see straight away 120, which means the angle here will be 120. Anyone like to guess then? I can hear them, everyone shouting this out. Yeah. So this will be, it is, let's see if I can be exact and not mess everything up and take you to different places with my mouse.
We've got somebody else.
60.
Well, somebody else already ahead, yeah, for 60 there.
Well done. So the angles in these four shapes are either 120 or 60. Is there a relationship between 60 and 120? Have a think about that. And whilst you have a think about that, I think, well, should we head over to our next activity, which is all about using these shapes?
Yeah, absolutely. So we're going to move on to a game now. So if I explain how the game works, first of all, and it's going to be, well, Fiona is going to play against me, but we're going to try and get you involved in this as well. So you'll be able to either be Team Fiona, or you can be on the better one and be on Team Andy, obviously. So we'll do that in just a second. And similarly with the rest of the chat as well, you can say either which shape or which color shape you want us to move. Slightly harder is going to be telling us where to put it, but we'll maybe tell you what we're thinking and then get some advice, yes, no, that sort of thing. So what we need to do with this one is we take turns to place any of those shapes onto the board, and after the first person's moved the first shape, every time that the person goes again, each new shape must touch one that is already on there. So it can be any of those four shapes. It needs to fit inside that board, but it must touch a shape that's already on there. And the person who places the piece that completes the whole thing is the winner. So you might be thinking about, oh, you might want to think to yourself on there. So how many times would those trapezoid shapes fit inside a hexagon, for example? Or how many times would one of those equilateral triangles fit inside a rhombus? So there's going to be a bit of strategy going on here, isn't there, as well, I suspect. So let me just make sure I can actually see the same board that Fiona's looking at as well. I'll put the chat up so that I can see what people are saying. So you could, I'm just trying to think how we do this for speed. So we could either type F for Fiona, A for Andy, I guess. And then probably if you just tell us a shape name, that's going to be the quickest way to do it, isn't it? So
yeah, we could just say H for hexagon, T for, oh no, we've got triangle and trapezium. Yeah,
so red, green, blue, yellow, maybe.
Yeah, yeah. I don't want to make you nervous, Andy, but I'm on a bit of a winning streak here.
Yeah, I forget you've done more of these.
Yeah.
But
Okay.
I was just going back to the last one I did where I was going to say an easy victory, but it was very close, wasn't it, in truth, towards the end. So do you want me to go first, or do you want to go first?
You choose, because I don't want to be accused of
Right, in which case, I am going to start off with the biggest one. I'm going to go for a hexagon, not anything original. I'm just going to put that straight in the middle.
right. So we've had someone saying put the triangle on the top, but do you know what I'll do? What should I do? Okay, I'm going to follow. So if I put triangle.
Yeah, so just while you're doing that, because some people might be thinking that you meant go right at the top of the playing board, but it's got to touch the existing shape, remember? So that person was exactly right. Go on top, but it has to go on top of the hexagon because it's got to touch something else. So let's see, which color should I go next? Anybody like to make a suggestion, or color or shape, whichever you'd like to do? So rhombus, somebody's saying, well, blue is actually what they typed, and side, it's a blue side. So I'm going to just move. I think what people are saying is move it to the side. So I'll choose to move it to that position on the side. Let me just try and turn that around a bit so it's a little bit neater. Looks to be about right.
Well done. Well, do you know, in my head, I was thinking, I'm going to try and cover as much of the board as possible. And then someone's popped in the chat at the same time with me having that thought, hexagon to go underneath. So I'm going
that can only go one place, can't it?
Yeah, I'm going to put that. Oh, gosh. Steady hand there. Okay.
Right. So so another, that was your instruction, wasn't it? Another hexagon underneath. So red, we've got red going. Red next to blue. Okay, we'll go with that one then. So let's try that. So the only place that can fit in then for red next to blue is to go just there, isn't it?
Perfect.
Is that overlapping? No, it's not. All right. Yeah, that's it.
Yeah, cool. Well, I've got more instructions, so I'm just doing as I'm told. I've got someone, and I'm going for the first suggestion, which was to put the triangle underneath the hexagon at the bottom. So there we go.
Okay, well, as you were doing that, there was another one. I mean, I don't know whose this is for. This might be for you, but if it is, I'm going to pinch the idea anyway. So somebody said red next to red. So can I fix a red next to red? I should be able to. If I go up to the top, I'm going to have to turn that round, aren't I?
Well, there should be a shape that's already in that orientation, but
so that right, let me just spin it around anyway, just to be
brilliant.
Nearly got it around.
I don't know if you've got any pattern blocks in schools, but these shapes are within pattern blocks, so they're quite nice. You can actually just use pattern blocks to play this game. Right, so I'm going to go, trapezium on the side. Was that your instruction?
No, mine was red on red, so.
Okay, well, I'm going to do that. Let me just move that way a bit. There we go. Now, there's not many spaces left. We could also start to strategize now, couldn't we, and work out?
We could. So if we think about what we were saying at the beginning, where the green equilateral triangle will go twice inside the blue rhombus, won't it? And so on. That's essential. We've got another trapezium in there. Somebody's saying, yeah, next to the blue. I'm going to put one next to the blue. Doing this on the wrong screen. I've got two screens going here. I keep looking down at the wrong one. So somebody wants me to put the blue next to the blue. I'm going to trust their judgment on that one. Okay.
So now I'm thinking now, if we did another rhombus, that's my turn. Now, then it could be, then it depends if we split it. Oh my gosh, this is really tricky. I'm going to go a triangle on the top because, oh gosh, I'm so sorry. Let's go again. Right, triangle on the top, and let's put that. Oh, it's stuck at the moment. It doesn't want to move. Come on, that's it. Right. I think my laptop slowed down a bit. I do apologise.
It's getting overexcited. That's what's happening.
There we go.
Right. So I'm in a bit of a tricky position, aren't I, here? Because if I fill all of one side in, that means Fiona can fill all the other side in.
Yeah.
But if I only fill half of one side with an equilateral triangle, Fiona can do the same on that. So yeah, I think I'm in a bit of a sticky situation here. So let me just do that anyway.
So I was starting to think a few moves ahead.
Yes, indeed. Right, that's my go.
Okay, so if
I think I know what's going to happen next.
Yeah, because if I put a rhombus in,
yeah, feel
I've got
free
lots
to
of
do
people
that.
saying, just put a triangle, just put a triangle. That's exactly what I'm
No,
doing.
I think you should go with the rhombus suggestion. I think that's a much better.
Oh dear, let's see if my laptop will.
Yeah, so ignore all those people saying one triangle on the side.
There we go. Now you could win this.
So right, yeah, that surprised me, that one. I thought you were going to go for triangle on the other side. So I'm going to go there.
I helped you win, didn't I?
You did, really, yes. I know you could have cooked, couldn't you, there? Yeah. So, but yeah, it's an interesting sort of strategy, isn't it? You can sort of think it several moves ahead towards the end of the game. Yeah. It's a bit harder to do that right at the beginning.
Yeah.
But it's good fun either way. It
is. But what's interesting is all of these shapes were able to fit together with no overlaps and no gaps. And remember, we were talking about the angles, weren't we, before? And obviously what they have in common is 60 or 120. And I wonder if anyone knows, when you can fit shapes together like that with no gaps, no overlaps, and you begin to make a pattern that you can keep extending, anybody got any idea what that's called? Because that's what we're going to have a look at now. So let me change screens and let's...
And if anybody can get this in the chat and spell it right, that's going to be impressive.
Yeah. It? So here's another clue. So what do you notice here? So we've got some paving and we've got just some other shapes. So some have just got one shape that's repeated. Others have got more than one shape, irregular shapes. And if I go to the next one, it's going to give it all away. There we go. They're called tessellations. Okay, so when shapes are repeated again and again and again with no overlapping, no gaps, it's called tessellating. And we've got a really simple one in the middle with the hexagons. Here we've got squares and triangles. They tessellate really nicely. Then probably things you might see in buildings. You might have some of this in your own home or even in school. You know, some pretty patterns with tiles and paving and things like that. And once again, all these are shapes that are tessellating. And then when we look on the right, we've got some really interesting things going on here. This is some artwork. And when I look at this top one, immediately a particular animal jumps out at me. What animal jumps out at you, Andy?
The cat is the one I can see easiest. Yeah.
So then you start to see the dog, don't you, behind?
Yeah, even though I've seen that one before, I still have to sort of strain a little bit to see the sort of light brown dog in between all the cats. But it does fit perfectly, doesn't it?
It does. And then if we look at the butterflies as well, I love the way they've managed to fit those butterflies together. And obviously you can see it really well because of the primary colours that they've used. So that got me thinking, because I do love my art as well as my maths. So I don't know if you've heard of an artist called Escher, but he was very much into mathematics as well, and looking at objects and trying to work out impossible things with objects as well, to give it like an optical illusion, if you like, but also looking at reflection and symmetry. And he did a lot of work on tessellating irregular shapes as well. And if you look here, we've got some like a chameleon or dragon, I don't know what exactly it is.
So it's like a little lizard, isn't it, that one?
A lizard, yeah, absolutely. And there's 3 different colors there. And then when I look at the middle one, I can see fish and a frog, and I just think it's so clever. How on earth are they managing to tessellate? And then we've got the fish as well. And that got me thinking. I was thinking, wouldn't it be fun if we could do something with irregular shapes and we maybe make up what's going to be within the shape? So I've got something to share with you, which I think is a very fun activity. So I'm going to stop sharing. And what I'm going to do is spotlight me so you can see what I'm just about to do. So I'm going to move my laptop so you can see the desk in front of me. Hopefully you can.
Yeah, that's fine. Well, just while you're getting yourself ready, Fiona, on there, somebody had suggested B. I think that might have been in relation to the butterfly one, but yeah, B I think would work pretty well like that as well.
So to do what I'm going to do now is I'm going to do a tessellation with a fun irregular shape. Is you need a square piece of paper, pen or a pencil, up to you. I've got both with me, pair of scissors, and then you'll need a bigger piece of paper that you can then do your tessellation and draw that on. So I've actually started to draw some lines just before we started this session, so I'm not wondering what to do. But you get your square piece of paper, and what's really important is you must go from one corner to the next corner, but it must be on the same side. So I can't go diagonal across, I have to go to the next one. So I'm going to, with a pen, just draw. You can just do whatever wiggles you fancy, but I've gone from one corner to the next. I then get my scissors, and if you're not very careful with cutting and you want it to be, you know, be careful, maybe get an adult to help you, or I have to do it so you can see what I'm doing. I'm doing this quickly because obviously it's not fun just watching me cut out, but try and be careful how you do it and make sure you go into that corner. Now, when you finish that, it's really important that you remember where that came from, the exact location, because this side here now, I'm going to move across so it joins this side here. So here we go. So if I move it across and put it there, and then just a little tiny bit of sellotape, that's all you need. And I'm just going to stick that together. Okay, now I could stop there, but I want to make this a really interesting irregular shape. So I'm just going to just very quickly do another one. So once again, I've gone from one corner to the other corner there, my scissors, and very quickly, oh sorry, let me do it so you can see, very quickly just cutting that out, being careful as I get to the end. And then remember, this is the opposite, so there, and then I put that there, get my sellotape to just keep it together, and now the fun begins. I get my sheet of white paper, and then what I'm going to do is I'm going to get a pencil, and I'm just going to very quickly, I'm doing this quickly, if you're doing this, I'm sure you're going to take hopefully a lot more care than I am, but once again, I want to get to the point so you can see where the magic all starts to happen. So I've drawn around my shape, and then if I move it across, you can see here, it fits in, so I can draw around it again.
Is it best to start in the middle of the big sheet of paper then, Fiona?
You know, I don't think it matters really.
Okay.
I don't think it matters, because you will find, whatever size piece of paper you have, you will find, oh, I'm going to try and work out where it goes next. Let's go, that goes there. So you will find that you end up going off, okay, but that doesn't matter. So it depends how big your sheet of paper is. And I can draw another one here. And I just keep going. And I could draw another one here. So I've just got bits of it joining. So I'm doing this quickly, as I said, you'll be far more careful. And then that, oh, look, that fits in there. So let's just quickly draw around here. Right, I'm going to stop there because obviously I don't want you to just keep watching me draw. Now, how about you have a look at the shape? And I'm thinking, what's jumping out at me? And I'm already, this is what I'm seeing. I'm going to draw here, and I'm going to draw that, I think.
Yeah, so if anybody's got any suggestions about what this creature or thing might be, then yeah, stick this in the chat as well, and let's see if you. Oh, all right, I'm trying to sort of see this upside down, I think.
Okay, I think everyone is at the moment. Right, so if I turn it around, you can see I've made it into a, I don't know, dragon, a wolf or something like that. So it's really quite good fun. So if all I did was just had a look at that shape and just thought, oh, what does it remind me of? If I show you, I did one of these earlier, gives you an idea. But what you could do, a bit like the Escher one, is have one as a wolf, and you could look at that and think, well, what else does it look like? And maybe draw something different in the other one. So yeah, some great fun with tessellating. But I think the thing that's really intrigues me is I had a square bit of paper. I've now got a very irregular shape. Why does it tessellate? And that might be something else to start investigating, thinking about why it works. Why am I able to do that? So great fun. As I said, I love my art and I love my math, so that's the two coming together. So what I'm going to do is very quickly just remove the spotlight, and I'm going to share my screen again. And there we go. And I think do you know what? Spot on. We've just fitted within our 45 minutes. So I hope you enjoyed all of the different activities. They are all in the handout that's going to come to you after this session. I hope you're excited about maybe having a try at some of those. And I'd love to see some of your irregular tessellations. I think it would make a lovely display in a school. So yeah, please, if you get a chance, maybe send us some so we can have a look. So thank you for joining us, and I'm going to hand over to Andy, who's just going to finish off. Thank you.
Yeah, just to reiterate what Fiona said there before. As I say, I've recognised some of the school names that are schools that I've attended. So, you know, if you want to get in touch with me, if I work with you generally, you know, for any other information or to share things that you've done, that would be fantastic. If it's not me, if it's one of my colleagues, they would equally, I'm sure, like to receive that as well. So just email that through to them. And just to remind you as well, all of that summer challenge material is up on the whizz.com website. You can just go onto there, have all of that. That's part of our complimentary service as well. Some really good, interesting stuff on there. I've got schools that have set up STEM clubs alongside all of this as well. So some really exciting activities that, particularly for this time of year, where you can get outside and do them. So yeah, thank you very much again for your time. Have I missed anything, Fiona?
No, I think just go and have some fun. Yeah.
Yep. So thanks again. Thanks again for coming along.
Thank you.